Hello. Okay, so we know that the roots of a quadratic equation, um, um, given by factorization, right? We can solve a quadratic equation by way of factorization. We can find its roots or its two solutions. Additionally, we could also use completing the square. And there's also a third method, and that is by way of using the quadratic formula, which looks like this: x equals minus b plus minus roots of b squared minus 4ac, all of that over 2a. Now what's inside the square root symbol here, b squared minus 4c? That is the discriminant, and this is a really extremely useful to know, and I will make a few videos on the discriminant in the future, because it offers a lot of useful information when analyzing a quadratic, but I'll save that for another time. Meanwhile, this is the quadratic formula, and what I'd like to talk about in this video is a proof of the quadratic formula by completing the square. In the recent video on completing the square, I frequently alluded to the fact that the method of completing the square appears very, very early in a proof of the quadratic formula. So I'm going to talk about that as well. But in the meantime, the proof of the quadratic formula, it is quite cool. It's I think maybe the first proof I learned. It's very simple, but it is fun and it is pretty cool. And what we're going to want to do is I'll just rewrite, okay, quadratic equation just in a real general form: ax squared plus bx plus c equals 0. And so what we want to do is we want to end up here, right? We want to end up with this quadratic formula. So how do we go about doing that? Well, the first thing I like to do is I like to transpose the quantity of c, which in other words, to put it more practically, is I just want to subtract c from both sides. So that leaves us with ax squared plus bx, which equals minus c. And now what one is going to want to do is divide by a right across this whole thing, right? And the reason for that is you want to have the coefficient of the x squared term here, basically just want it as 1. So we're going to divide by a right across. That's of course going to leave us with x squared plus b over a x equals minus c over a. Now this is the cool part. I mean, in my opinion, I think it's quite cool. And the reason for that is we're essentially ready on the left hand side here to complete the square. Okay, and now we already know that in completing the square, we want to basically have the coefficient of the x term, right? And then we're going to take what that equals, and we're going to put it over to the right here, and we're going to square all of it, and we should end up with a perfect square if we have done it correctly. So how do we go about that here? Well, what is half of b over a? Well, that would be b over 2a. So what we have then is x squared plus b over a x plus, and I'm just going to put this in parentheses, b over 2a squared. And again, that is equal to c, minus c over a. But what we add to one side, to the left hand side, we've got to do to the other side, the right hand side. So I'm going to add b over 2a squared on the right hand side as well, right? This is just basic, just for the algebra to work. We have to, what we do to one side, you've got to do to the other side. And so now, what we have on the left hand side, the whole point of completing the square, and actually before I get to that, we can simplify this a little bit more. So it's going to be x squared plus b over a, and the reason I say we can simplify it is we can just distribute this. It's just going to be b squared, right? And then 2a squared is 4a squared, okay, minus c over a. And I'm just writing everything out to make it very explicit, like this. So as I was saying, the reason we want to complete a square, and this is again really cool, is because what we end up with here is a perfect square. Perfect square. It's the whole point of doing it, of completing the square here. And we know that a perfect square, we can simplify this, and again, let's think of it really generally as a plus b squared, right? We basically want to get all of the stuff on the left hand side in this form, in this general form, right? We know this is a perfect square, we know this is a perfect square, so how do we do that? Well, there are a few ways of thinking about it. I mean, you could look at the b squared over 4a squared term if you want, or you can just think in terms of about the coefficient of the x term here, the b over a. What is half of this? Well, we already know that that's b over 2a. So this can be simplified as x plus b over 2a, and then I'm just going to put parentheses around it, and then the whole thing is going to be squared, right? Because now if we were to FOIL this out, if you will, or just use the distributive property twice, we would end up with all of the stuff in the line above, x squared plus b over ax plus b squared over 4a squared. Okay, so now we have here, this is going to be set to equal c minus c over a, and we still have this b over 2a squared, and I'm just going to go ahead again and distribute that, so it's just going to be b squared plus 4a squared, just as it was up here. So that's really cool. From lines about 3 to line 5, this is the really cool part, in my opinion. I mean, the ending is very cool as well, but just the whole method of completing the square here is very, very cool. And now we've got everything into the form that we want. And so I'm just going to, we can work on the right hand side a little bit. The left hand side is basically exactly where we want it for now. Okay, so we've got our perfect square, that's everything is good there. And so on the right hand side we have this minus c over a plus b squared over 4a squared. So we need to add this together, and to do that, well, we can think, well, the denominator here is 4a squared, so we just want to basically multiply both the numerator and denominator of this term by 4a squared, or by 4a, I should say. And so what that's going to give us, and I'll just write this all out, 2a squared. We're multiplying both the c and the a here by 4a, so that's going to leave us with minus 4ac over 4a squared plus b squared over 4a squared. And why that's very, very useful is now we can just simplify everything on the right hand side, and so on the left we have x plus b over 2a, all of that squared, of course, and then this is just going to be and I'll write the b squared term first, just so we can recognize sort of what's taking shape here. So we have now b squared minus excuse me, 4a squared, all of that over 4 squared. Excuse me. Oh, my allergies are acting up. So we have b squared minus 4a squared, all of that over 4a squared, or minus 4ac, I should say. So now the next thing that we can do, and one might already start to notice what's happening here, what's taking shape. I mean, if we scroll back up and we take a look at the quadratic formula, you can see it, the discriminant of b squared minus 4ac, all of that over 2a. Well, you can see here we've got our b squared minus 4ac term at the top, right where we want it. And so now what we can do is basically take the square root of both sides, right? So that's going to be x plus b over 2a, and that's going to equal, and I'll just square root sign, and then we've got our b squared minus 4ac, and then the denominator is just going to simplify to 2a, and this of course is plus minus b squared minus 4ac over 2a. And now this is, I suppose, the final step is, and one might already recognize what needs to happen, because again we're just going to transpose quantity of the b over 2a term here, okay? In other words, we're just going to subtract it from both sides. And what does that leave us? So, well, that's going to leave us with x equals, and I'll write it like this, minus b over 2a plus minus root of b squared minus 4ac, all of that over 2a. And now we can of course just simplify this. The denominators are the same, and so what we have is minus b plus minus the root of b squared minus 4ac, all of that over 2a, and we have the quadratic formula. Very cool. It's quite simple, but it is lovely. It's a lot of fun. And yeah, that's it.